packet pushers.
Hello and welcome to the Network Automation Nerds podcast, where we explore the latest in network automation from a practitioner's perspective. I'm your host, Eric Cho, a network engineer who loves everything about network automation. On today's sponsor episode, we get into network infrastructure required to support AI workloads. Our sponsor is the Siemens company, which makes cabling to connect data center servers and switches. Our guest is Gary Bernstein, Senior Director of Global Data Center Sales. Welcome to the show, Gary. Can you tell us a quick overview of the Siemens company?
For those of you not familiar with the Siemens company, we're a global manufacturer of structured cabling products. And actually, this year marks 121 years since Siemens was founded. Kind of crazy. We're still privately owned by the Siemens family, and we're led by a fifth generation family member now, Henry Siemens. He took over as CEO about 3.5 years ago. And so we're really focused on copper and fiber cabling solution, two primary markets, really the intelligent building, commercial building space, and data center markets. We operate in over 100 countries and have Siemens facilities in several strategic locations to support our global customers.
That's a long time. I don't think there's generative AI 100 years ago, was there?
No, definitely not. Yeah.
So certainly the company evolved over time. And of course, our topic today is the infrastructure required to support the generative AI workloads. I think my understanding is that in this field, we're actually dealing with two types of requirements, model training and inference training. So what are the differences between them?
Gen AI really is about creating an application to solve problems. That starts first with creating a model. And yeah, there are two types of models. There's training and inference models. Training is really just learning a new capability from lots of existing data, which uses a process called deep learning. So for example, if you want to have an application that can distinguish between a dog and a cat photo, you would have to feed that model with just tons and tons of data and photos and videos of all different types of cats and dogs to be able to distinguish from one to another. And then inference is really just applying this new capability to new data that comes in. ChatGPT is probably the best, example that most people are familiar with of an inference model at that point of an application.
So an inference sort of like refines an existing model with new information. Is that the idea?
Well, it doesn't really refine it. It uses that capability. So the model has to be developed first for a particular use case, for a particular application. And then once it's ready to be deployed and used, that's really called the inference point and model at that point.
Our, I think, purpose here is to talk about the infrastructure. So what are the key considerations to build out data center infrastructure if I'm going to run a model, train a model, or build an inference model?
So there are really four key areas that are unique to AI networks. First, the very high bandwidth requirements, dramatically increased power consumption, the utilization of InfiniBand in addition to Ethernet, and extremely low latency requirements. The power and the cooling requirements are probably the single biggest challenge that is really forcing complete redesign of data centers for this application. In the past, let's give you an example. The average kilowatt kW required for a full server rack has been around in the kind of 5 to 15 kW range. Now, if you think about an AI server, each server requires anywhere from 6 to 14K per server. So now, like a full server rack can require anywhere from 30 to over 100 kW per rack. And the reality is most of the data centers that exist today cannot support this type of power and cooling. So it's kind of forcing, again, dramatic change. In a traditional air-cooled environment, we're seeing data centers limit the number of servers per cabinet. So they're kind of spreading things out much more, which is resulting in using more fiber, for example, for switch to server cabling. There's other things that are being done from a cooling standpoint to be able to support that and to get higher density. The two next levels, so liquid to chip. So basically, you're putting that chip right on the server so you can increase your capacity and density, and even full immersion cooling, where you fully immerse an entire cabinet loaded with servers in a liquid. And now you're talking over, 100, 150 kW to be able to do that. In terms of the fiber cabling I mentioned, for the switch to server cabling, this can be either done with like fiber cabling with transceivers or AOCs, active optical cables. The next kind of key area that I mentioned is the difference is real the bandwidth requirements. They're also very big. I mean, it's just the training models are typically using 200, 400, or 800 gig per GPU. That compares with a typical data center server speed of about 10 to 25 gig.
Right.
So much higher. I mean, and that requires a lot more fiber, than a traditional DC. It could be up to 10 times more fiber, because of that. First of all, the number of connections and the speeds. So for example, like an AI server, one server typically has like 8 GPUs.
Mhm.
And if you're using 400 gig per GPU, that would be like 64 fibers for just one server.
Wow.
If you've got 4 servers in that rack, that'd be 256 fibers for one server rack. Pretty crazy.
And all of that has to get wired into a top of rack switch, essentially?
Not always, actually. That's a good point, because the reality is, because of that density changing, we're not typically using top of rack switches anymore. It's more of a end of row or middle
Okay.
of row
Mhm.
because of that. So it goes in that's what traditionally we've seen as top of rack switches being used, and you're patching directly from the top of rack into the servers. But because of that, that's why I was talking about spreading things out more. When you're spreading things out more, the servers, you're not typically putting those switches at the top of rack. Like I said, it's the end of row, middle of row, and that row could be 20 cabinets long. The super pod from Nvidia is 8 compute and 2 network cabinets as an example. So that's 10 cabinets right there. They're showing a middle of row, but that's just kind of a guideline. But yeah, it's pretty crazy. The last piece I was just going to highlight on that, one of the big changes that we're typically seeing both in Ethernet and InfiniBand being used. InfiniBand has been around for many years, but it's been pretty limited, honestly, in terms of market adoption. It's been primarily for prior HPC applications.
Mhm.
Siemens is actually a member of the InfiniBand Trade Association. That's the standards body for InfiniBand, like IEEE is for Ethernet. And so we're actively involved in both IB and Ethernet standards developments. But it is important to understand the difference between the two protocols. So that is another unique challenge with these AI networks.
My understanding is one of the reasons InfiniBand has sort of morphed over from HPC applications to AI is because it was designed to be essentially lossless out of the gate, whereas Ethernet, its core design is not meant to be lossless.
Exactly. So, I mean, it's lossless, and the other key kind of difference is the latency. So InfiniBand has a much better latency. Really, it's Rocky technically. So Rocky is the Ethernet-based protocol. So Rocky is RDMA over converged Ethernet. That's kind of the other option versus InfiniBand that's being used. But yeah, exactly.
Yeah, so it definitely makes sense to use InfiniBand because of the lossless network. And I think you mentioned some of the advantages of using InfiniBand, low latency, that sort of stuff. What other challenges are there in using Ethernet? Because that's more wide adopted for AI workloads.
From what I understand, it really is the two key ones that we talked about in terms of the lossless communication, and that Rocky is not as good as InfiniBand, and the latency. Those are the two key current, I'll say, disadvantages of the Ethernet-based protocol.
So, how are the silicon and networking vendors trying to address these shortcomings that you mentioned?
So there is a lot of work being done there. Many of the leading Ethernet ecosystem manufacturers and cloud companies working together, and they formed something called the Ultra Ethernet Consortium
Mhm.
middle of just last year in 2023. And that includes companies like leaders like Broadcom, Intel, AMD, Arista, Cisco, and some of the big CSPs like Microsoft, Meta, and Oracle. And so there's like 70 member companies now, I think. But the goal of that UAC is to develop a really complete architecture that optimizes Ethernet for high performance AI and HPC. Better than today's Ethernet product. So they plan to have an industry spec, it states, by the end of this year, 2024. But we actually are starting to see new switches already being announced that are UEC compatible. Arista just recently, in the end of June, they announced their EtherLink AI platforms that they say is UEC compatible.
Mhm.
So there's a lot. I mean, those are some big boys, obviously, in the market, and they're working hard to improve the overall performance. And so, in terms of, if you look at market share, I guess, just kind of adding to that a little bit, in terms of the between IB and Ethernet, today it's probably 85% InfiniBand.
In the AI space in particular, or AI and HPC?
For the AI backend networks.
Mhm.
So the backend networks is really the new piece of the equation for these data centers. The front end is kind of the traditional leaf spine networks, but the back end is really the new piece of it. Companies like Del Oro and 650, they're forecasting though Ethernet to eclipse the InfiniBand volume within the next few years. So they're pretty bullish on the growth of Ethernet. And the reality is, it is an ecosystem, Ethernet, and there's a lot of manufacturers, and that is one downside of IB. I think everybody knows that there's really primarily one company, Nvidia, that owns that space. Customers even that I work with, they want options. They want multiple options. And today they don't have a lot right now. So
I think there's probably also more folks who know how to build Ethernet networks than there are who know how to build and operate and manage IB networks. And that can make a difference as well.
that is true as well. Yes, IB is definitely foreign to a lot of people. We've worked with several folks to try to help them with that transition and understanding what the differences are.
So I want to just circle back, if we could, for a second to the power discussion, because you were giving us some astonishing numbers. And is that high level of power consumption essentially due to the GPUs and the servers, or is because we're also talking about upwards of 800 gig in the network? Does the network also have a role to play in those power numbers?
No, what I was quoting was just the GPUs and the servers.
Oh, okay.
That was just the servers, yeah, due to the GPUs, yes.
Okay. And so you also mentioned then fiber or active optical cable as options. Are there power considerations when I'm thinking about fiber or AOC?
So, the difference between, so like an AOC or a DAC, the power utilization there is significantly lower than a transceiver, as an example. So if they're using a transceiver with fiber cabling, it's a pretty significant difference there. And the latency is actually, and that's one reason why, some companies, recommend doing that, all point to point with direct attach or AOCs, because the latency is typically better with them on the short, but once you get to larger scale, it's difficult to do that on very large deployments.
Can you go over a little bit of difference for people who are not familiar with, the DAC cables or AOCs? What are the differences of different materials, different reach, different power level?
There's really 4 different options, more or less. DAC. So a DAC is a direct attach cable. It uses a twin-X copper cable, and they utilize various different connectors on there that are, the interface, they connect directly into, that GPU or the NIC card, excuse me, or the switch. So like an SFP plus, SFP28, QSFP28, OSFP, QSFP-DD, those are all different interfaces. Another variation of that is an AEC, active electrical cable. So that's a copper cable that allows you to go a little bit longer reach than a DAC. That is one downside of a DAC. You're limited to, it depends on the speeds, but call it 2.5, 3 meters, maybe, sometimes a little bit longer for the lower speeds. And then we've got AOCs is an active optical cable. So it uses the same interface connectors I was talking about, but it uses fiber. So you can go a little bit longer reach, as I was talking about. So you might go, once you're over 3 meters, maybe up to 10 meters. Once you get probably, in that 10-meter range, you're probably going towards fiber cabling with patch panels, typically, because it starts getting pretty difficult and messy to pull, AOCs and the connectors through cable tray and so forth.
Yeah, so it's really just a mixture of, say, fiber or copper and active and passive, and it really comes down to the reach and the cost, just because of the number of cabling that is required for this workload. Is my understanding correct?
Yeah, the reach, the cost, power is the factors we talked about too.
Power, yeah.
So you're right; those are definitely part of it.
How much does the network power come into play, though, if the GPUs are using so much electricity already? Does that really matter if I'm in my design? It's like saving pennies, right? When you're spending millions.
It's like just for the power allocation, I imagine this empty room with like one rack of server, just because that's the power that's been allocated to it.
It is, yeah. It's crazy amount. That's why it's very difficult, and a lot of people are scrambling to get space that's capable of putting in these networks.
So I know we touched on it a little bit, but I think it feels like we're dealing with such different infrastructure for AI workloads. Can you talk us through a little bit more about what the server infrastructure looks like?
Sure. So a typical AI server kind of looks like this. There's either 4 or 8 GPUs for the compute side connections, 2 or 4 connections for storage and in-band management, and then 1 out-of-band management port. Earlier, as I mentioned, the GPUs are running at kind of 200, 400, or 800 gig. And today it's typically using InfiniBand, which, for terminology purposes, it's either HDR, NDR, or XDR, or Ethernet is an option as well. So the storage and in-band are running at 100 or 400 gig, but that is utilizing Ethernet. And then the
Mhm.
out of band is an RJ45 connection, 1 gig Ethernet is all that's required for that. So that's kind of what it looks like. You've got, in terms of the companies, how that is being offered to the market, you have companies like Supermicro, Dell, HPE, Lenovo that are, in addition to Nvidia, that are offering these servers. Those guys will use their GPUs and provide that full service solution.
Yeah, the way that you described it, Gary, it almost seems like there's one housing, but inside of that housing, it's each GPU is being treated, or cabling wise, it should be treated like an individual server just because of the number of connection, the workload that each of them handles.
Yes, correct.
Yeah, so as you touched on before, Nvidia is obviously the leader in the space. I can't even think of the next player. You could probably correct me on that. But so, what are the flagship products for the Gen AI market from Nvidia?
Sure. One thing, as a partner, Siemens actually is a partner with NVIDIA. So we're considered a solution advisor consultant
Mhm.
with NVIDIA. And so we're part of their NPN program. But NVIDIA has been developing new GPU technologies really incredibly fast over the last several years. Just to kind of go back a little bit, so they introduced the A100 in mid 2020, which that
Mhm.
was really for 100 or 200 gig. Then they came out with the H100, which was less than 2 years later in early 22, and that was based on the Hopper chip technology, and that was for up to 400 gig. Excuse me. And just in March of this year, NVIDIA announced their new Blackwell chip and the B200 GPU that can support up to 800 gig. This was actually supposed to start shipping later this year, but I just saw that it got pushed out a little bit to early next year for them. And so NVIDIA offers their DGX platform and their DGX servers as their brand for their servers with these GPUs, or the server partners that I was just talking about, SMC, for example, would supply the NVIDIA GPUs as part of their overall solution. So those are kind of the bread and butter ones that we're seeing mostly in the market and the up and coming solutions.
So I can buy my GPUs and get it in an enclosure from NVIDIA if I want, or I can also go to my favorite OEM and they'll also sell me the GPUs in their enclosure with their badge on it.
Correct.
Is there any sort of functional difference between them, or is it just like, I'm used to HPE and I've got their management software or whatever, so I'm going to go with that? Or is it more like it's a tight market and I'll buy it from whoever can sell it to me?
What I am seeing though with these companies like SMC and others, they're also acting as a system integrator. So they're
Mhm.
providing kind of a full solution.
Mhm.
So the end users like that, really the ones that we've worked with, and they have options there too. So whether they're kind of looking at SMC and Dell or whatever and comparing those guys. So, the software stack is still similar. If you're doing an NVIDIA, for example, you got to still use their software stack as part of it. But I'm sure there's benefits, with the, Dell server or an SMC server overall. But I don't know what the mix is exactly. But last I saw that the majority of the volume is probably going through the partners in terms of the GPUs being, provided. I mean, just from a scale standpoint, NVIDIA can't handle it anyway,
Sure.
in terms of the total volume. I think, what was the number I saw? I think it was the last year, I think it was 2 million H100s GPUs
Wow.
that they shipped. It's just crazy, the volume that is being shipped right now and installed.
Yeah, well, here's a chance to correct me from my last question. Right? Like, we're talking about NVIDIA. So, if they have any competitors in the GPU space, what are some of your options, or do you have any outside of NVIDIA?
Yeah, there's really two other primary GPU manufacturers. That's Intel and AMD.
Mhm.
Neither of them offer InfiniBand, right? It's only the Rocky solution.
Mhm.
So Intel has their Gaudi platform, Gaudi 2 and Gaudi 3. AMD has their, what they call their, like the MI 200 and MI 300. So those are, they're trying to, develop those markets. I mean, I will say just very recently, I just saw, I think it was a couple of days ago, Intel announced a $1.6 billion loss second quarter of this year. They're laying off like 15,000 people. So that doesn't look great for them. I'm just saying, because I know, if you look at the press release, they do highlight obviously their investment in AI. They've spent billions to build up their capability, and they haven't realized that revenue yet. So I'm sure, I don't know if that's the only piece of it, but that's probably a big piece of it. So those guys are playing catch up, definitely. But obviously, as I mentioned before, that at least the market forecast experts think that that's going to change over the next few years.
I think I remember seeing something in an Intel press release about the Gaudi 3. They were saying it's more energy efficient. Do you think that would resonate with customers as Intel tries to find a foothold in this market?
I'm sure it would. Exactly. I will say that the other, just on the Ethernet side, back to that, Nvidia does, I think I mentioned this, but Nvidia does offer both InfiniBand and Ethernet. So when I talk about the Ethernet market, that includes them in there as well.
Yeah, for sure. The amazing thing about NVIDIA is they've got the GPUs, then they've got the networking on both sides. So they're all set.
They're trying to do everything, actually.
Yeah. What's sort of the smallest pod size that an enterprise could start with? And then how big could they get, assuming, if they've got like a nuclear reactor next door they can pull power from?
You know who's doing that, right? So yeah, if you're just, let's talk NVIDIA, for example, they do offer what they call base pod reference architecture. And that's targeted at enterprise companies and starts with like 2 or 4 nodes, designed to support up to 10 nodes. So these servers, really just terminology, node, same as a server in this case, they're crazy expensive. I mean, it's about $300,000 for one server.
And this is coming with 8 GPUs. A node has 8 GPUs.
Yes, exactly. That's what the eight. Yep. So the reality is enterprise companies will have to invest cautiously probably until they see that ROI. And you got to be a big enough company to be able to invest that in the CapEx, right? And then NVIDIA's next level of architecture is called their SuperPod, and that's based on 32 nodes in a scalable unit. But that can be scaled out and up to 128 nodes. So, really enterprise will likely probably go up to 32 nodes, depending on the company. Beyond that's really targeted for the CSPs.
And in terms of architecture, I was assuming, sort of top of rack leaf spine. Is that what people are doing when they're building the network infrastructure for their AI workloads?
Yes, it's still leaf spine, but it's just not as top of rack.
Okay.
And, leaf spine and super spine in some cases too. So for the compute side, so you're going from your server to your leaf switch, your leaf to your spine, and then potentially super spine,
Okay.
on the larger networks.
Right, depending on how many pods I assume you have.
Right, exactly.
And Ethernet and InfiniBand both doing leaf spine?
Yes.
Yeah, so you talked about because of these pods and connections, there's a big investment on the CapEx, in the company, they're waiting to see the ROI for these investments. And so we're talking about Gen AI applications. Obviously, ChatGPT is the best well known. So what are other use cases that we could use Gen AI for?
So really, I think it's still pretty early days, honestly, on use cases.
Yeah.
But from what I've seen, there's really a lot of potential use cases in a variety of different markets. So, again, I'm going to reference back to the market leader right now. Per NVIDIA, the top 3 areas that they highlight and are focused on are healthcare,
Mhm.
financial, and autonomous vehicles. In terms of those, and within each of those, there's several different use cases or applications that are being evaluated. I think people are still trying to figure that out, what the best is, but there's a lot of different potentials there. I mean, we look at autonomous vehicles, I think it's pretty public knowledge that, Tesla is building one of the largest data centers in the world for that purpose. And so just as an example.
When we're talking about data centers for, autonomous vehicle, it's not that real-time reaction, right? It's actually processing the data in the back ends or, analyzing so to train that model.
Exactly. It starts with the training, as we talked about. So that's why they're, all that data, right? I mean, if you use the cars, right? Everything that the streets and the lights and everything, right? It obviously have to input all that data to be able to train that model and then to be able to use that in their vehicles, obviously. And they've been doing that and trialing that for a while now, I know, in other companies as well. I mean, I was in, was it Waymo?
Mhm.
Uh-huh.
Yeah, I was in one of those in San Francisco not that long ago. It was amazing that, it actually did better than I expected, with people walking up on the sidewalk or whatever and stopped and instead of a taxi, so it was it's crazy. It's amazing what's going on.
Is it weird riding in the back of a car with nobody driving?
Yeah. Strange.
I was gonna ask that if we could get the cop who stopped the Wemo for like crossing over and trying to find out where the driver is or who to talk to and just kind of knock on the window with nobody's driving. That would be a trip.
So if people are thinking about building out infrastructure for AI, what should they be thinking about in terms of their cabling, particularly if they want to future-proof this?
Well, I think it's kind of hard to totally future proof for Gen AI, but I guess I would say, knowing where the speeds are at today, it's probably best to design, a cabling infrastructure. First most has to have flexibility
Mhm.
and also allow you to support, I would probably say at this point, speeds, of 800 gig or 1.6 terabytes to be able
Wow.
to support the types of applications that folks are doing today. So, I mean, there's a lot of different variables there, but at a high level, I guess that's probably what I would say.
So I'm going to put you on the spot there, Gary. So
Yeah.
if you were to build data center cabling, if you were to recommend or build for Gen AI today, would you pick InfiniBand or Ethernet?
Honestly, from my standpoint, it doesn't really matter, honestly. And from a cabling standpoint, so if you look at it from a fiber cabling standpoint, it doesn't matter. The fiber cabling is the same regardless, if it's running in InfiniBand or Rocky. Once you get to like some of the high-speed cables I was talking about, the DACs and the AOCs, it does matter. So it needs to be either InfiniBand or Rocky. So there is a difference there. I mean, the reality is, Ethernet obviously has been around a long time, and there's a very large ecosystem, and that's why it's likely that that's going to grow even more over the next several years. I would expect that to happen.
Are you hearing from data center operators who are looking to build out offerings to help people train AI models who can't build this infrastructure or don't want to build this infrastructure on-prem?
Yeah, there's a couple different paths there. I'm not sure which way you were thinking, but there's several, I'll call startup companies that are basically providing compute as a service.
Mm-hmm.
And really, I mean, that's kind of a whole new industry a little bit in itself. Guys that are, again, these startup companies that are building very large AI networks for other companies, right? They're competing with Amazon, Microsoft, and Google, but just in this space. So, yes, that is one path. And we are seeing that around the globe happening in those companies, and they are being pretty successful. And that is a way for an enterprise company to, get into it by buying compute as a service, really is what it is, right? The other path that you were talking about too, even for an enterprise company, if they don't have the ability to do it on-prem, using a colocation company, some of them have really expanded their capabilities in terms of the power and the cooling side of it and the infrastructure to support those networks. So if they want to keep it in-house, let's say in an on-prem, but in a colo, that's another very common option that we're seeing too.
Okay, so if I'm maybe for whatever reason not wanting to go to the full public cloud in AWS and Azure, I could check my local colo providers and see if they've got facilities on hand that could do this for me.
Yeah, but the colo guys are not offering compute as a service, just to clarify. So just like they always do, they're offering space.
Okay.
Mm-hmm.
So if I want to buy my hardware and put it into their space, that's what I'm referring to.
But they'll make sure the power is going to be there for me. And
Correct. Exactly. Yeah. They'll make sure the power and the connectivity and all that is there. Again, just like the public cloud came out, whatever, 20 years ago or whatever with AWS.
mm-hmm.
I mean, it really is the same thing all over again. It's just another application in the cloud. So those guys, like I said, the CSPs are providing that compute as a service per GPU. You can go on, you can look, there's a different price for an A100 or a different price for an H100. And so that is definitely becoming very common.
I checked the price. It's not for the faint of heart. I mean, just think about all the capex they invested in. They have to make it back somehow.
Exactly. It's the same old, CapEx versus OpEx, which, from an enterprise company standpoint, which way they want to go.
And I'm just imagining the bill coming in when you actually want to pull your data out of that cloud. That's where they're going to get you. Okay, so for the last question, then I know we touched a little bit on some of the cabling issues with AI infrastructure, but Gary, last thoughts on what people need to be thinking about, because you obviously can't forget the cabling if you're going to be building out some Gen AI infrastructure.
Definitely not. Yeah. Well, really, let's see, with 4 different networks, very high bandwidth and very high density requirements, the cabling designs, they can get fairly complex. That's the reality of it. Each of the networks typically require, that switch to server and switch to switch cabling. Like, as I mentioned, like on the power side, that, capacity per rack is a major factor. It really is. It becomes an important point. So, for example, if they can handle higher kW per cabinet, we might see using DACs, AECs, and ACCs, like I was talking about, with that top of rack switch for those switch to server connections. But if they have to spread out the servers more, we would typically see fiber cabling or AOCs being used. For switch to switch, it would pretty much always be fiber cabling most commonly. We are seeing as a best practice to use a hybrid cabling design. And what I mean by that is really a combination of point-to-point and structured cabling. So, for example, you'd have point-to-point, let's say my node to leaf switch could be point-to-point, but then between leaf switch and spine switch to be structured cabling. So that really is, kind of what we're seeing. Many customers, have tried using point-to-point for all their cabling. They've realized that this can turn into a real mess. It gets very hard to manage. It's not very flexible, and it's not scalable. Hopefully that helps with the advice on that.
Yeah, for sure. So if folks want to get more information about the Siemens company, where should they go?
Probably the best place is just our website, Siemens.com. We do have a specific AI landing page on there, Siemens.com/AI, I think it is, and can take a look at all of our AI ready solutions.
All right, that's Siemens.com, SEIMON.com, or also Siemens.com/AI.
You got it.
Yeah, thanks for being here, Gary. There's really insightful for, things that you don't normally think about, such as cabling, such as, active, passive, the type of connections and materials that you use. But it really is a lot of IPs and insights on just that. It brings me back to the early days of the cloud, and where it's the cloud for everybody else, but for us it's power cooling and all the physical stuff.
Exactly.
You having flashbacks, Eric?
Yeah, having a little heart attack back here. Well, thank you for listening to this episode of Network Automation Nerds. Do you have any feedbacks for Network Automation, our guest today, or this episode? Send us some follow-ups at packetpushers.net/FU, where FU stands for follow-ups, of course. We want to hear from you. Check out our website at packetpushers.net to find other network engineering focused podcasts, blogs, YouTube videos, and much more. You can find podcasts such as Network Breaks for weekly shows, Heavy Networking for deep dives, Packet Protector for security, and so much more. Last but not least, remember that too much network automation would never be enough.